identity. Now, again, you got to remember also the tangent identities. They're not that hard to remember because there's patterns on these formulas. So the first thing I'm going to do on this one, like all of these, is I'm going to go through and figure out how to either take two angles and add them or take two angles and subtract them and get 105. There are many ways to do it. What comes to my mind is 60 degrees plus 45 degrees, okay, like that. And of course, you got to have angles that are on the major angles on the unit circle that we've learned. Okay, now this is how I remember the tangent identity, is it goes like this. I'm going to write the first step just kind of down here. The numerator is just the tangent of 60 plus the tangent of 45. That's what the identity tells you to do, okay? Same sign, and then the denominator goes 1 minus, it has a different sign, then it's the product of the tangent of 60 times the tangent of 45, like that. So we're going to go ahead and just kind of fill this out as we go. One thing on the tangent identities is the algebra is more complicated. It's just got more algebra going on it. And then the other thing on this is let's just kind of consider unit circle, because the rest of the problem is just looking at the unit circle. And, you know, when you get into like your second test, I do give you a blank unit circle to fill out, but you don't have to. What I do on these problems is I just figure it out as I need to. So like, what is the point at 45 degrees? You probably have that one down. I mean, students always seem like they got that one down. It's not hard to remember, okay? 60 degrees, I always reason this out. I know it's got a half and a square root of 2 in it, but the thing is, I just got to know which is which. Oh, come on, what's that thing doing? Okay, so it's going to go like this. It's going to go 1/2 square root of 3 over 2. The way I figure that out is the x value is small, the y value is big. Does that make sense? Okay, that's all I remember, okay, and then I'm in good shape. Okay, so if you do a tangent, you're doing y over x, right? So if we're going to do the tangent of 60 degrees, okay, we're going to do y, which is square root of 3 over 2, divided by 1/2, and you can do this in your head if you want to. I don't care. I just want you to get that right. So then you do this. So that's going to give square root of 3. Okay, so we have that. And then if you do the tangent of 45, that certainly is easy to do in your head. What is that going to be?
1.
It's going to be 1, right, because y over x there is just the same number divided by itself. Okay, so what we're going to do now is we're going to go back, fill those things into the identity. Then the rest of the problem's algebra. Okay, so the tangent of 60 degrees is square root of 3. The tangent of 45 is 1. And then at the bottom we're going to have 1 minus square root of 3 times 1. So we're going to end up with the square root of 3 plus 1 over 1 minus the square root of 3, like that. Okay? Now that's not finished. Okay, so does that make sense how that's working so far? Okay. Okay, so basically you're doing the identity and then you're working this out. Now the rest of this is you got to know what is the algebra behind this. Okay, so you got to rationalize the denominator. We haven't done this very much, but if you have 1 minus square root of 3 in the denominator, what do you do to rationalize it? Yeah, you multiply by the conjugate. Okay, you don't just multiply by square root of 3 because it doesn't work. So what I'm going to do is we're going to multiply the top and the bottom both by the conjugate of the denominator, okay? If you haven't taken algebra in a long time, that's something that you may have forgotten about, so that goes, you need to work that out like that, and then that'll rationalize the denominator, see, okay? All right, so it's just now kind of FOIL. So if we do the numerator, you got 1 times square root of 3 is square root of 3. Outside term is square root of 3 times itself. What is the square root of 3 times itself?
3.
That's 3, because it's really square root of 9, so it just becomes 3. Okay, the inside term is 1 times 1, and then the outside term is 1 times square root of 3, so that's square root of 3. Okay, so that's the FOIL. Okay, Now, when you go to the denominator, I'm going to FOIL that, but you can bypass that because something happens anyway. So the first term is 1. The outside term is plus square root of 3. The inside term is negative square root of 3. So what's going to happen to those two things? They're going to cancel. That's why we did this, by the way, is because we take advantage that they're going to cancel. And then the last term, what is the square root of 3 times itself again?
3.
It's 3. Okay, and it's a negative times a positive, so it's a negative. Okay, so you got to be on top of that and make sure you know how to do that. Now notice what we're going to have. The numerator, you're going to have 3 plus 1 is going to be 4. Okay, then the square root of 3 plus the square root of 3, those are like terms, so that's 2 times the square root of 3. Okay, the denominator, you have this that cancels, and then 1 minus 3 is negative 2. Now we rationalize the denominator. Am I finished? No, because you got some reducing, and the best way to do this is just, and I don't care if you do this in your head, and just write the answer in your head, but the idea of what you're doing is you have that. Okay, you're breaking it up into 2 parts, so the final answer is, of course, that's negative 2. These cross out, but that gives you a negative square root of 3, like that. Okay, so that's the solution of the problem. Okay. So the idea would be, and one other thing I want to just kind of mention on this problem, because when you're getting answers, you always want to take the attitude, I got an answer, does it make sense? Okay. What quadrant is 105 degrees in? It's in quadrant 2. Okay. Is the tangent positive or negative in quadrant 2? Negative. Did I get a negative answer? I sure did. Okay. So you got that approach, and then the other thing you can do is you can check these on your calculator. So you could actually take the tangent of 105 degrees and then type in your answer, and they should match. So I showed how to do that a little bit. Okay. All right. Does that make sense? Okay. When you're dealing with tangents, you're going to get into, rationalizing denominators and that kind of thing like that. Okay. Any questions? Okay. All right. Let's move on below here then. Okay, now what we're going to do on this is we're kind of doing these backwards. I don't know why these things are showing up here. No, that's fine. These are in the right place. I was thinking they were in the wrong section, but we're okay. So what I'm doing on this one is I'm really giving you the right side of which identity, the cosine sum identity or the sine sum identities? The sine. Remember, the sine is the one that goes sine, cosine, cosine, sine, same sign. So this is going to be a sine identity for either adding or subtracting. Well, here's the key. Okay, remember on a sine identity, the sign is what? It's the same. Okay, so that's going to be plus, and then you got 10 degrees and you got 50 degrees like that. Okay, so you're doing it backwards. Okay, you're just doing this to help you learn the identity better. Okay, it's an exercise and that's its purpose. So that's the sine of 60 degrees. Okay, don't go running for your calculator. And I would suggest if you're doing problems like this, don't even go running for your unit circle. Figure it out as you go. Learn to do that. So 60 degrees is this point. What is that point? 1/2. X is small. Square root of 3 over 2. Y is big. So what's the answer of this problem? Square root of 3 over 2. Yeah, okay, it's the Y value like that. Okay. So again, once you kind of get this put together, then it's just kind of an exercise in working with your unit circle. Okay? All right? Okay, and then the next one is, again, it's sine, cosine, cosine, sine with this sign. So you're going to do this the same way. You're going to say it's a sine identity, and it's going to be 115 degrees minus 55 degrees. Okay, like that. And then that is going to be sine of 60, I guess, again. So obviously we get the same answer, okay? But the thing that I want to make sure you guys understand on this, that's really the most important thing, is that these signs match up. That's how you know. That's really all you got to think about, and the rest of it's unit circle, okay? Okay, any questions there? Okay, I think you guys, for the most part, are going to find the 3.4 and 3.5 and the 3.3 to be easier than 3.1 and 3.2. I mean, that's just kind of my experience. It's a little bit more straightforward, okay? Any questions? Okay, I'll just slide this down just a little bit. And then let's do a tangent identity like this, okay? So it's the same idea. This is the right side of a tangent identity. Okay, the only question is it a tangent plus or is it a tangent minus? What do you think it is? It's a plus. It's because of this. Look at that sign. That's what tells you that. If you look at the identity, if you have a tangent sum, then it translates into a sum in the numerator. So you're going to say tangent of 5 degrees plus 25 degrees. So that's going to be the tangent of 30 degrees. Okay, so now it's just unit circle time, right? And you can do this. You could even do this if you wanted to. I'll do this just for variety, just for something different. You could look at a 30-60 right triangle and do it this way. A lot of times on tangents, I just do it this way, okay? Because if you do y over x, you have complex fractions, so it just goes 1, 2, square root of 3. So the tangent of 30 is going to be opposite over adjacent, right? So that would end up being 1 over the square root of 3. And then if you rationalize that denominator, which you could do in your head, you guys have done that enough by now, you just kind of rationalize in your head, don't you, for the most part? Okay, that's your answer. Now you could also go to the unit circle. If you did go to that point on the unit circle, you would end up having the point square root of 3 over 2 and 1/2, and if you did y over x, you'd get the same thing. Okay, work out the same way, so it's up to you. Okay, so that's just recognition of identities is all you're doing, and once you get those things put together, you go to the unit circle. Okay, any questions so far? Okay. All right, now generally the other thing that I like to do in this section is maybe a couple of proofs. I'll let you guys go ahead and just do these next two problems, if you will, number 9 and 10, and do that. Does anybody still need to copy this last thing? I'll keep those up here if you need to copy those. But go ahead and do the problem number 9 and 10, and we'll see if we're on the right track with that then, okay? Go ahead and you can finish them up. I'm going to go and put them together. Once you catch on to it, it's not much to it. So, number 9 is a sign identity. What sign did you use? That's the key. Plus or minus? Plus, okay? That's because of that sign being a plus. That's how you know that. So what you're doing is you're doing the sine of 120 degrees. Okay, that's a unit circle problem. Okay, so I'm just going to go the unit circle. I know I'm in quadrant 2, and I know I've got 3 key points out here. And the angles on this go like 120, 135, and 150, okay? So what is this point for 120? Okay, now it's going to be negative 1/2 because x is negative. The y value is as big as possible, so that's got to be the big one, square root of 3 over 2. So what's the answer? Square root of 3. Square root of 3 over 2, good. Okay, like that. All right, problem done. Okay, next problem. All right, the key is, did you use tangent sum or did you use tangent difference? Tangent difference. Okay, so it goes like that. So now you're going to be doing 155 minus 35, which is kind of a good deal. It's 120, so we've already got that point established. So what did you do? You do y over x, right? Okay, so when you're doing this, go to that point. Y is the square root of 3 over 2. You're dividing that by x. You are going to get a negative answer. The tangent of a quadrant 2 angle is always negative. So that's square root of 3 over 2 times negative 2 over 1. That cancels. So the answer is square root of 3. Negative square root of 3, like that. Okay? All right, does that make sense to everybody? Okay, all I'm trying to do is familiarize yourself with the identities. That's it. Okay? The most practical thing that you learn how to do is where I give you an angle and you use the identity to find the precise answer. That's the idea, okay? All right, so let me slide this down just a little bit here. And then I want to do this problem. Got a little bit more thought involved in this problem. This problem's a little harder to do. Okay, so what we're doing on this one is I give you some information. So I'm giving you the cosine of an angle A is a third, and I'm giving you that that angle is in quadrant 1. I'm giving you the sine of a different angle, B, is negative 1/2. and I'm giving you that fact. You have to be given that fact to nail this down. The question is, you want to find the sine of angle A minus angle B. And you don't have to figure out what A and B are. It doesn't matter. Okay, you can do this problem analytically without even having to figure out what A and B are. And in fact, the only way you could figure out angle A and angle B would be to use your calculator and do like an inverse cosine and an inverse sine. But we don't need to do that. What we're going to do to start with is we're going to write down our sine difference identity. Okay, so sine identities go sine, cosine, cosine, sine, okay, like that, with the same sign. Okay, so that's the identity that you know. So what we're going to do on this is we're going to just analyze the given information, and then that will figure this out. Now notice on this I gave you the cosine of A. Okay, so that 1/3 is going to go there. I gave it to you. Okay, we know what that is. Notice that I also gave you the sine of B. Okay, so that is negative 1/2. That's going to go there. Okay, so the whole problem, the whole point of this problem really boils down to you finding this and you finding this. If you can figure those two things out, you got it made, right? And I did give you enough information to figure that out. So what I'm going to have you do is, since A is in quadrant 1, we're going to draw a diagram, and we're just going to do like a reference triangle. Okay, so we know we're in quadrant 1. Okay, so this is for angle A. And what I'm going to do is we're going to draw a reference triangle and label that angle A. Okay, and I gave you all the information you need to know on this problem. Okay, so we've done this plenty of times this semester. If I gave you the cosine is 1/3, what two variables did I give you?
Y over R.
Careful. X over R. Okay, the definition is X over R, right? So that means X is going to be the base of the triangle. We know that R is the radius, and that just leaves us to find Y, which is easy to do. That's Pythagorean theorem time, right? So we just need to use the Pythagorean theorem to find Y. Okay, so we're going to do x squared plus y squared equals r squared. So that's going to be 1 squared plus y squared equals 3 squared. So that's 1 plus y squared equals 9. You can subtract 1 from both sides to get y squared equals 8. And then you can square root both sides. Okay. Technically, that's a plus or minus. And then remember, you can break up the square root of 8 into 4 times 2 to get plus or minus 2 radical 2. Okay? But which is it? Is it positive or negative? Okay, how come? Because with the quadrant we're in. Yeah, you're in quadrant 1, so we end up having 2 radical 2 with that then. Okay? Now, what are you supposed to do? You're supposed to find the sine of A. So we could do the sine of A easily enough now by doing what two things? We just do y over r, right? So y is this, r is this, so that's going to be 2 radical 2 over 3, okay?
But B is in quadrant 4.
Now I'm doing A right now. I haven't even got the angle B yet, okay? Yeah, because we're going to do angle B next, but we had to do that angle A in order to figure out what the sine of A is. Okay, does that make sense? Okay, I'm not doing anything new. This is stuff we did a long time ago, right? Pythagorean theorem and all that stuff and definitions, we just kind of keep coming back to. So now we'll work with angle B. And in this problem, it says that angle B is in quadrant 4. So what I'm going to do on this is I'm going to draw a picture of a reference triangle in quadrant 4. And then angle B is going to be that angle right. Hold on. You know what in the world am I doing here? Okay, look at me. Gosh, I need a spring break. Where is quadrant 4? Help your teacher out. Gosh. Okay, so we're down here. Okay, that's quadrant 4. All right, so now what we have on this is if I give you the sine, what two variables do I give?
Y over R.
I gave y over r, right? So y Is y going to be 1 or is it going to be negative 1?
Negative.
Going to be negative 1 because it's down. R is always positive, so we have that. Okay? Now, x, you could use the Pythagorean theorem, or you could just tell me. You might just already know it. I already know it. Do you? Good. Square root of 3. Hey, this is a 1, 2, square root of 3 triangle. It's a special triangle. It doesn't matter what the angle is, though, so we have that. Okay, so what we need to do now to finish up this problem is what is the cosine going to be in this triangle then? Square root of 3 over 2, right? Okay, because it's x over r. So we have that. Then I'm going to bring that minus sign down. Then what we're ready to do is just crunch out the arithmetic, and then we're done. Okay? So we would end up having, when you multiply this out, one thing you could do is cross the... I'm not going to do that. There's a reason I'm not going to do that. Let me show you why. If you do this and multiply this out, you get negative 1 over 6, right? I like having a common denominator, see? Okay, so I'm not going to even bother crossing those things out. I'm just going to write this as 2 radical 6. I'm multiplying those radicals over 6 like that. Okay, does that make sense? Yeah. Well, if I cross the 2's out, I'd have to turn around and get a common denominator anyway, so I'm going to bypass that. So I'm going to have 2 radical 6, and then this becomes plus 1 all over 6, and that's the exact answer of the problem, like that. Okay? All right, any questions with that? Okay, now let me explain something on this too. What we did is we did a sine. We just did a sine, and we never knew what the angles A and B were because it didn't matter. But let's think about this. I got a positive answer, and that must mean that we're either in quadrant 1 or 2. I want you to think about this for a minute. What do you think happens if you add a quadrant 1 angle to a quadrant 4 angle? What's logical? Where would you end up being? Well, if you have a quadrant 1 angle and a quadrant 4 angle added, wouldn't that probably put you up in quadrant 1? Okay. Now this is a difference of 2 angles right here. So what happens on this is you're really doing a quadrant 1 angle minus a quadrant 4 angle. But since we got a positive answer, it's going to tell us that this happened. I want to show you this on the calculator. And you don't have to write this down. I just want you to pay attention to this. Because you want to think about why your answer turned out the way it did. I'm going to put my calculator in degree mode because it's a little easier to interpret it. And see, I'm going to take the given information. I'm going to go inverse cosine of 1/3. And that gives you 70 degrees. Okay, so I'm going to write down that angle A is about 70.5 degrees. And that was a quadrant 1 angle. So that was given to us. Now I'm going to do inverse sine of negative 1/2. And that's going to give me a negative angle now. Okay, because of the range of an inverse cosine from negative 90 to 90. So really angle B would not be that. It would be 330 degrees because it's a quadrant 4 angle, right? Okay. Now what we just did in this problem is we really did A minus B. So if you did 70.5 minus 330, let's figure that out, and that'll tell us what quadrant we're in. So if we did 70.5 minus 330, we have negative 259.5. In your head, where is that angle? It's in quadrant 2. Is the sine of a quadrant 2 angle positive or negative? Did I get a positive or negative answer? Got a positive. Okay. Does that make any sense? Okay. All right. Well, I mean, you can kind of think through the problem that way. You don't have to, but it's a good idea to kind of, help you understand what you did. So with that problem, you don't have to find the angles. You just have to do the analysis. Okay. All right. On the last page here, I'm going to finish this up with a couple of proofs. Okay. Not really proofs. We're going to use identities to just come up with a few things, and we'll go to the next section here. Okay, so these are actually very easy to do. Okay, I'm wanting you to do the sine of alpha plus 2 pi. There's only one way to do it, and that is to pull out the sine identity. So we're going to do the sine sum identities, which goes sine alpha times cosine of the second, same sign, then do it backwards. You're going to have cosine alpha times sine of 2 pi. Okay, so I'm just pulling out that identity, and that's all I'm doing. Now we need to just think about the unit circle. If you're at 2 pi radians, what is that point on the unit circle? 1, 0, right? Okay, so we're going to bring down the sine of alpha. Okay, what is the cosine of 2 pi? It's the x value, so it's 1, right? Okay, now we're going to bring down the plus sign, and we have cosine of alpha. So what is the sine of 2 pi? It's 0. So that's your sine, that's your cosine. So we got that, okay? Now look what happens. Of course, one of them is going to go to 0, so you're going to end up having sine alpha times 1 is just this, and then that's 0. So you would get the sine of alpha like that. That's the answer to the problem. Okay, it's simplified, okay? Now, to me, I'll see if this makes any sense to you. This makes perfectly good sense to me based on what I know about graphing. What is the period of a sine wave? So does it make sense if I just take an angle and add 2 pi to it, I'm just back to the same point? That's what the problem says, okay? That's the idea, right? So if you graphed the sine of alpha plus 2 pi and graphed the sine of alpha, they're the same graph. They're exactly the same function, okay? All right, let's look at this next one. Okay, now this one we're going to pull out the tangent sum identity. So you got to memorize that. The tangent sum identity goes tangent alpha plus tangent of pi. That's your numerator. Then it's going to be over 1 minus tangent of alpha times tangent of pi. Like that. So that's how that identity goes. Okay. So what we need to do is we need to look up on the unit circle what's going on at pi radians. So what is that point at pi radians? It's -1, 0, right? Okay. All right. So what is the tangent of pi going to be since it's y over x?
0.
Right. That's going to be 0. Okay. So what we do is just replace the tangent pi with 0, and you're going to end up having tangent of alpha plus 0 over 1 minus tangent of alpha times 0. Okay, like that. So if you work out all the details, it looks like you're going to have tangent of alpha in the numerator, and then the denominator is just going to be 1. So you're going to end up with the tangent of alpha. Okay? So what we just showed is the tangent of alpha plus pi is equal to tangent of alpha. Now that I'm hoping that would make sense to you. What's the period of a tangent? Pi. So does it make sense if you take an angle and add pi to it, you would get the same answer? Okay, it's because that's what the period of the tangent is. Okay, so that's the idea. Okay? All right, any questions with that? Okay, let's just take a couple minutes to do those next two down there, and then we'll move on to the next section. Okay, you can look up your identities earlier in the packet if you need to. So on number 14, you're doing the sine difference identity, and number 15, you're doing the tangent difference identity. So just work them out. Pi over 2 and 360 are on a unit circle, and then you'll find out what you have. Okay, so let me go ahead and run through them. I went ahead and just wrote out the identities. That's the first thing, and should be able to do that fine. It's just knowing the identity. Okay, so on 14, what is the cosine of pi over 2?
0, 1.
0. Okay, so you got that. There's your 0.01. The cosine is 0. So you got sine alpha times 0. And then what is the sine of pi over 2? 1. Okay, so a lot of times on these things something cancels out. So that's going to go to 0, so your answer should have been negative cosine alpha, like that. Okay, so like if I was wanting you to prove that the sine of alpha minus pi over 2 is negative cosine alpha, that's how you would do it. It'd be a real easy proof. Just pull out the identity. Okay, now I wrote the tangent identity. Go ahead. What's that again? Yes, and the negative came from this, that sign right there, because you're doing 0 minus a number, so it's negative cosine alpha. Yeah, well, the identity for a sign has the same sign. So since that's difference, that comes down, so that's why it's negative.
I mean, negative cos alpha equals cos alpha. So an even function.
Oh, are you thinking about? I'm not sure what you're thinking about there. Oh, okay. It's an even function, so you don't really need to do anything with that. You might be thinking about cosine negative alpha or something like that. You don't need to do anything with that. Okay, so that's done. Okay, this next one you got tangent of alpha. Okay, now what is the tangent of 360?
0.
Yeah, okay, it's y over x, so it's 0. Okay, and then down the bottom you would have 1 plus tangent alpha times 0. So that's tangent of alpha in the numerator over 1. So the answer is tangent alpha, like that. Okay? All right? So those shouldn't be too bad. Any questions about that?